The critical step of recrystallization is to find a solvent in which the impurities are very soluble at low and high temperatures, while the product is only sparingly soluble at low temperatures but very soluble at high temperature. Let me explain how this works. You have your crude solid, which is made out of product P, and impurities I. You add the solvent at its boiling temperature until the solid is just dissolved. Recrystallization relies on the fact that as temperature increases, solubility of a solid usually increases. Once the solid is dissolved, we let the flask cool down. If the solvent has been chosen correctly based on the impurities and product desired, the product will precipitate as pure crystals since it has a lower solubility at the lower temperature, giving us an opportunity to extract it while the impurities remain dissolved in the solvent. There will be some product still dissolved in the solvent while we extract the crystals, but we are going to sacrifice quantity for quality. To make sure the recrystallization process goes well, there are a few hints that can help us. First, we need to add a minimum amount of boiling solvent to make a saturated solution. If we use too much solvent, the solution will be too dilute and the product will not precipitate. Secondly, we need to make sure to let the flask achieve room temperature before putting it on ice. If we directly put the flask on ice, the solution will crystallize rapidly, and the impurities will be trapped between the pure growing crystals, precipitating with the product. In this experiment, the solvent of choice for recrystallization is water. Once the pure salicylic acid is isolated, washed and dried, we can weigh the product to calculate the percent yield. It's important to also measure the waste and impurities throughout the whole experiment in order to calculate the ultimate material cost. Now that we have a recrystallized product, let's make sure it's actually salicylic acid. This is where chemists do characterization. The first method is to measure the infrared spectrum, which lets us compare the key functional groups in the starting material to that of the product. Another method is to determine the melting point and compare it to the literature melting point of the product. These two methods are the quickest and simplest to use for known compounds. Now that we have an intermediate product, which has been purified and characterized, we are ready to conduct the second step to synthesize ASA.